Welcome class 8 students. I hope you are enjoying your day as well as your studies. So I am your maths teacher and from today onwards we are going to start with our maths chapters. So in today's class we will do chapter number 1 of our books, which is rational numbers. So let us start with. So far we have studied that counting numbers, that is 1, 2, 3, 4, 5 etc. are termed as natural numbers. The sum of two natural numbers is always a natural number. The product of two natural numbers is also a natural number, but subtraction of two natural numbers is not always a natural number. It may be 0 or a negative number. Thus, we had to introduce the concept of whole numbers and integers. Now consider the case when a natural number is divided by another natural number. For example, when 4 is divided by 5, we get the number 4 upon 5, which is not a natural number, whole number or integer. Thus, we have to introduce another system of numbers. This new system is called rational numbers. So, 4 upon 5 is a rational number. Similarly, 2 by 3, 3 by 4, minus 5 by 7, etc. are all rational numbers. Thus, positive integers, negative integers, 0, common fractions belong to the new system of rational numbers. Thus, any number which can be expressed in the form p upon q, where p and q are integers and q is not equal to 0, is called a rational number. So, every rational number is the quotient of two integers such that the denominator is not. Now, let us see some of the properties of rational number. Let us start with property number 1. If p upon q is a rational number and n is non-zero integer, then p upon q will be equal to p into n upon q into n. That is, if we multiply the numerator and denominator of the rational number by same non-zero integer, then rational number remains unchanged. All the rational numbers thus formed are called equivalent rational numbers. Let us see one example now. So here we have to express minus 4 upon 5 as a rational number with denominator minus 20. So let us see how we put in number 2. If p upon q is a rational number and n is a non-zero integer, then p upon q is equal to p divided by n. That is, if we divide the numerator and the denominator of a rational number by the same non-zero integer, then rational number remains unchanged. For example, so in this example, we have to express minus 30 upon 78 as a rational number with the numerator equal to 10. So for that, now since in the given rational number, numerator is 30 and we want a rational number with numerator 10, that is rational number with numerator less than the given rational number. That is a rational number with numerator less than the given rational number. So we will divide the numerator and denominator of minus 30 upon 78. Since 30 divided by 3 is 10 and we have minus 30 in the given fraction. So minus 30 divided by minus 3 will be equal to 10. So we will divide the numerator and the denominator of the given rational number by minus 3. So we will get minus 30 upon 78 will be equal to minus 30 divided by minus 3 upon 78 divided by minus 3. So this will be equal to 10 upon minus 26. Now let us see property number 3. For each rational number x, only one of the following is true. First one, x will be greater than 0. Second is x equal to 0 and third x is less than 0. So this property says a rational number either would be positive, would be negative or 0. For example, if x is equal to 5 by 10, so which one of the following will be true? X greater than 0, x equal to 0 or x less than 0. Any positive rational number will be always greater than 0. Therefore, x is greater than 0. Thus, 1 will be true. Now, let's see property number 4. For any two rational numbers x and y, exactly one of the following is true. That is, x will be greater than y or x will be equal to y or x will be less than y. For example, if x is equal to minus 4 by 5 and y is equal to 9 by 5, so which one of the following will be true? X greater than y, x equal to y or x less than y. So here we are given x equal to minus 4 by 5 and y equal to 9 by 5. Since denominator of the given rational numbers are same, so the rational number with greater numerator will be greater. So therefore, y is greater 1. So we can say x is less than y. Thus, third will be true. Now let us see property number 5, which says if x, y, z be rational numbers such that z is greater than x and x is greater than y, then z will be greater than y. Or when x is greater than y and y is greater than z, then x will be greater than z. For example, if x is equal to 5 by 10, y is equal to minus 5 by 10 and z is equal to 7 by 10. So which of the following will be true? X greater than y greater than z, or z less than x. So since denominator of all of the given rational numbers are the same, so the rational number with greater numerator will be just between x and y. We get x is greater than y, that is 5 is greater than the numerator of y, that is minus 5. Then between x and z, we get that z is greater than x because the numerator of z, that is 7, is greater than the numerator of x, that is 5. So here we get x is greater than y and z is greater than x. So that means z will be greater than y. So thus 1 will be true. So these were all the basic properties of a rational number. Now we will see properties of addition for rational numbers. So let us start with property number 1. The sum of two rational numbers is always a rational number. This is called closure property of addition. In general, if a by b and c by d are any two rational numbers, then a by b plus c by d will also be a rational number. For example, 1 by 2 plus minus 3 by 4 will be equal to 2 plus minus 3, which is equal to minus 1 by 4, which is a rational number. So here we have a note. See this carefully. A by b plus c by d will be equal to LCM of b and d, both the denominators, and in the numerator we have a into LCM of b and d divided by b plus c into LCM of b and d divided by d. Now property numbers can be added in any order, the sum remains the same. This property is called commutative property of addition. In general, if a by b and c by d are any two rational numbers, then a by b plus c by d is equal to c by d plus a by b. For example, if we add 1 by 2 plus minus 3 by 4, so this will be equal to minus 1 by 4. And if we add minus 3 by 4 plus 1 by 2, so again this will be equal to minus 1 by 2. So thus 1 by 2 plus minus 3 by 4 is equal to minus 3 by 4 plus 1 by 2. Now we have some points to remember. Let's see them very carefully. Point number 1 is every natural number is a rational number. But every rational number need not be a natural number. 0 is a rational number because 0 can be written as 0.2, 0.3, 0.13. That is, we can write 0 in the form of p upon q, where q is not equal to 0. So since the denominator is non-zero integer, therefore 0 is a rational number. Every integer is a rational number, but every rational number is not necessarily be an integer. Every fraction is a rational number, but every rational number need not be a fraction. Now let us see property number 3. While adding 3 or more rational numbers in any order, sum of the rational numbers is same. This property is called associative property of addition. In general, if a by b, c by d and e by f are three rational numbers, are any three rational numbers, then a by b plus c by d plus e by f will be equal to a by b plus c by d plus e by f. Well, let us consider the sum of 5 by 6, minus 1 by 3 and minus 3 by 4. So first of all, we will add 5 by 6 and minus 1 by 3. This will be equal to 5 plus minus 2 by 6, which is 3 by 6. And then we will add minus 3 by 4 to this. So after solving, this will be equal to minus 3 by 12. Also, when we will solve minus 3 by 1 plus minus 3 by 4 first, so this will be equal to 5 by 6 as it is, plus also when we will solve minus 3 by 1 plus minus 3 by 4 first, so we will write 5 by 6 plus as it is. Now since denominator of both the fractions are different, so first we will find the LCM of 3 and 4, which is equal to 12. So we can write it as minus 4 by 12 plus minus 9 by 12. On solving, we will get minus 13 by 12. Now we will solve 5 by 6 plus minus 13 by 12. Again, denominators are different, so LCM of 6 and 12 is 12. So now this will be equal to 10 plus minus 13, which is equal to minus 3 upon 12. In both the cases, the final result is minus 3 by 12. Thus, 5 plus minus 1 by 3 plus minus 3 by 4 is equal to 5 by 6 plus minus 1 by 3 plus minus 3 by 4. Now let us see property number 4, rational number, and 0 is the rational number itself. This is called property of 0, and 0 is the identity element for addition of rational numbers. In general, if a upon b is any rational number, then a upon b plus 0 is equal to 0 plus a upon b is equal to a upon b. For example, 2 by 3 plus 0 is equal to 2 by 3 plus, now we can write 0 as 0 upon 3. So now we have a common denominator, so we will add the numerator part, which is 2 plus 0, which is equal to 2. So this will be equal to 2 by 3. And 0 plus minus 5 by 7 can be written as 0 by 7 plus minus 5 by 7. Again, we have a common denominator 7. So we will solve the numerator, that is 0 plus minus 5, which is equal to minus 5. So again, the rational number is minus 5 by 7. So any rational number added to 0 is the rational number itself. Now let's move on to our next topic, which is negative of a rational number. For any rational number a upon b, there is a rational number minus a upon b, such that a upon b plus minus a upon b is equal to 0. We say that minus a upon b is the negative of a upon b, and a upon b is called negative of minus a upon b. For example, 5 by 7 plus minus 5 by 7. So if we solve these two rational numbers, so here we have a common denominator 7. So we will solve the numerator part, which is 5 plus minus 5. So this will be equal to 0.7, which is equal to 0. Also, minus 4 by 3 plus 4 by 3 is equal to minus 4 plus 4 upon 3, which is equal to 0 upon 3, or we can write 0. So that means a upon b plus minus a upon b is always equal to 0. Let us see one example. So here it says what should be added to 3 by 4 so that the sum may be equal to 0. Sum of a rational number and its negative is 0. Since the given rational number is 3 by 4, so negative of 3 by 4 is minus 3 by 4. Now 3 by 4 plus minus 3 by 4 is equal to 0. Hence the required number is equal to minus 3 by 4. Now we have properties of subtraction of rational numbers. I hope you have understood all the properties of addition of rational numbers. So now we will start with properties of subtraction for rational numbers. So let's start with the property. If a upon b and c upon d are any two rational numbers, then a upon b minus c upon d is also a rational number. For example, 4 by 5 minus 3 by 10 is equal to 4 into 2 minus 3 into 1 upon 10, which is 8 minus 3, which is 5 upon 10, or we can write 1 upon 2 in the lowest form. So here 1 upon 2 is again a rational number. Properties of subtraction for rational numbers. Now we have properties of multiplication for rational numbers. So let us start with property number 1. The product of two rational numbers is always a rational number. This property is called closure property of multiplication. In general, if a upon b and c upon d are any two rational numbers, then a upon b into c upon d will be again a rational number. For example, if we have 1 by 3 into 4 by 5, so 1 into 4 is 4, 3 into 5 is 15, so this is 4 by 15, which is a rational number. Also, minus 3 by 2 into 2 by 5 is equal to minus 6 by 20, which we can write minus 3 by 10 in lowest form, is again a rational number. Now let us see property number 2. Two rational numbers can be multiplied in any order, the product remains the same. This is called the commutative property of multiplication. In general, if a upon b and c upon d are any two rational numbers, then a upon b into c upon d is equal to c upon d into a upon b. For example, minus 3 by 7 into 5 by 8 is equal to, so we will multiply the numerator part with the numerator part and denominator part with the denominator part. So this will be equal to minus 15 upon 56. Similarly, 5 by 8 into minus 3 by 7 will be also equal to minus 15 upon 56. Thus, minus 3 by 7 into 5 by 8 is equal to 5 by 8 into minus 3 by 7. Now let's move on to our next property, which is property number 3. For the product of 3 or more rational numbers, then the product remains the same in any order. This is called associative property of multiplication. In general, if we have a upon b, c upon d and e upon f are any three rational numbers, then a upon b into c upon d into e upon f is equal to a upon b into c upon d into e. For example, let us consider the product of 2 by 9, 1 upon minus 2 and 6 upon 5. So first we will solve 2 by 9 and minus 1 by 2. 1 upon minus 2 first, so this will be equal to minus 2 upon 18. Now we will multiply it by 6 by 5. So we will get minus 2 by 15. Similarly, now we will solve 1 upon minus 2 by 6 upon 5. So this will be equal to 6 upon minus 10. But since 6 and 10 both are divisible by 2, so we will divide them. And in the lowest form, it will be equal to minus 1 upon 5. Now we will multiply this rational number with 2 by 3. So we will get minus 2 by 15. So in both the cases, the final sum is same, which is minus 2 by 15. Thus, 2 by 9 into 1 upon minus 2 into 6 by 5 is equal to 2 by 9 into 1 upon minus 2 into 6 upon 5. Now letter 4. The product of any rational number with 1 is a rational number itself. Thus, if a by b is multiplied by 1, then the product is a by b. That is, 1 into a by b is equal to a by b. For example, 2 by 3 into 1 is equal to 2 by 3 into, we can write 1 as 1 upon 1. So multiply 2 by 1, that is numerator part with the numerator part, and multiply 3 by 1, which is denominator part into denominator part. So we will get 2 by 3. Also, 1 into 2 by 3 can be written as 1 upon 1 into 2 by 3, which is again 2 by 3. Thus, 2 by 3 into 1 is equal to 1 into 2 by 3. Similarly, if we multiply minus 5 by 9 by 1, so this will be equal to minus 5 by 9. Also, 1 into minus 5 by 9 is also equal to minus 5 by 9. So thus, minus 5 by 9 into 1 is equal to 1 into minus 5 by 9. Now let us see property number 5, which says any rational number when multiplied by 0 gives product as 0. In general, if a by b is a rational number, then a upon b into 0 is equal to 0 into a by b equal to 0. For example, if we multiply 5 by 9 by 0, so we can write 0 as 0 upon 1. So this will be equal to 5 into 0 upon 9 into 1, that is 0 upon 9, which is equal, that is 0 into 5 upon 1 into 9, which is equal to 0 upon 9, which can be written as 0. Let us see one more example, which is minus 3 by 11 into 0. So this will be equal to minus 3 by 11 into 0 upon 1. That will be equal to 0. Also 0 into 3 by 11 will again be equal to 0. Now here we have a point to remember. It says a rational number 1 is called the multiplicative identity for rational numbers. Now let us see property number 6. For any three rational numbers, a upon b, c upon d and a upon f, we have a upon b into c by d plus e by f equal to a by b into c by d plus a by b into e by f. It is called the distributive property of multiplication over addition. For example, consider the rational numbers minus 2 by 5, 2 by 3 and minus 3 by 2. So minus 2 by 5 into 2 by 3 plus minus 3 by 2 will be equal to, so first of all we'll add 2 by 3 plus minus 3 by 2. So this will be equal to minus 5 by 6. And after multiplying it by 2 by 5, we will get 10 by 30. Now we will solve the RHS part, that is minus 2 by 5 into 2 by 3, which is minus 4 by 15. And minus 2 by 5 into minus 3 by 2, which is 6 by 10. Now we will add both of these products, that is minus 4 by 15 plus 6 by 10. So after solving, we will get 5 by 15, which in lowest form will be equal to 1 by 3. So in both the cases, the final resultant is 1 by 3. Hence, minus 2 by 5 into 2 by 3 plus minus 3 by 2 is equal to minus 2 by 5 into 2 by 3 plus minus 2 by 5 into 2 by 3. Minus 2 by 5 into minus 3 by 2. So minus 3 by 2 should be there, not 2 by 3. Now let us start our next topic, which is of a rational number. We know that the product of a rational number and its reciprocal is 1. Similarly, the reciprocal of a rational number is another rational number such that their product is 1. Thus, a rational number into reciprocal of the rational number is equal to 1. Therefore, reciprocal of minus 3 by 8 is 8 by minus 3, or we can say minus 8 by 3. Because 8 by minus 3 is expressed in the standard form as minus 8 by 3. Now in this example, we have to find the reciprocal of the following rational numbers. First one is, so its reciprocal will be 9 upon minus 2, or we can say minus 2 upon 9. So in the first part, we have minus 2 by 9. Now since minus 2 by 9 into 9 by minus 2 is equal to 1, or we can say 9 by minus 2 into minus 2 by 9 is equal to 1. Therefore, 9 by minus 2 or minus 9 by 2 is reciprocal of minus 2 by 9. Similarly, let us see the second part now. Since 7 by 2 into 2 by 7 is equal to 1, or we can say 2 by 7 into 7 by 2 is equal to 1. So therefore, 2 by 7 is the reciprocal of 7 by 2. Now let us start with the properties of division of rational numbers. So property number 1 says when a rational number is divided by another rational number except 0, then the quotient is also a rational number. In general, if a upon b and c upon d are two rational numbers, then a by b divided by c by d is also a rational number. For example, 2 by 3 divided by 8 by 6. So to divide them, we will replace the division sign by multiplication sign and write the reciprocal of 8 by 6, which is 6 by 8. After multiplication, this will be equal to 1 by 2, which is again a rational number. Similarly, in the second part, we have minus 2 by 5 divided by 1 by 2. So again, we will replace the division sign by multiplication sign and write reciprocal of the second rational number. So reciprocal of 1 by 2 is 2 by 1. So after solving this, we will get minus 4 by 5, which is again a rational number. Now let us see property number 2, which says division of any rational number by itself gives the quotient 1. So in general, if a by b is any rational number, then a by b divided by a by b will be equal to a by b into b by a, which is equal to 1. For example, 3 by 4 divided by 3 by 4 is equal to 3 by 4 into 4 by 3, which is equal to 1. Now we have property number 3, which says when a rational number is divided by 1, the quotient is the rational number itself. For example, 7 by 3 divided by 1 will be equal to 7 by 3 into 1 by 1, which is equal to 7 into 1 upon 3 into 1, that is 7 by 3. Number 4 is when 0 is divided by any rational number is always equal to 0. For example, 0 divided by 3 by 5 is equal to 0 and 0 divided by minus 6 by 7 is also equal to 0. Now we have some points to note. Point number 1 is the reciprocal of a positive rational number is positive and the reciprocal of negative rational number is negative. Second point says there is no rational number which when divided by 0 gives 1. Therefore, 0 has no reciprocal. The reciprocal of 1 is 1 and reciprocal of minus 1 is minus 1. Thus, 1 and minus 1 are only rational numbers which are their own reciprocals. The reciprocal of a rational number is also the multiplicative inverse. Now, let us move on to our next topic, which is rational numbers. We know that the absolute value of an integer is the number with no regard to its sign. Recall the absolute value of minus 3. So, absolute value of minus 3 is 3. Absolute value of 3 is equal to 3. Absolute value of 0 is 0. So, the absolute value of rational number is also given by the same rule. For example, absolute value of minus 2 by 5 is equal to 2 by 5. So, we will remove the negative sign and absolute value will always be the positive one. Similarly, absolute value of 3 by minus 2 is 3 by 2 and absolute value of 3 by minus 4 is 3 by 4. Remember that absolute value of every rational number other than 0 is positive. The absolute value of 0 is 0 itself. Some points to be noted. So let us read them one by one. Point number 1 says the sum of two rational numbers is always a rational number. Second point says rational number can be added or multiplied in any order. So these are the points which we have studied till now. So these points will help us to revise all of the things. So now point number 3 is while adding or multiplying 3 or more rational numbers, they can be grouped in any order. Point number 4 says the sum of any rational number and 0 is a rational number itself, whereas the product of a rational number and 0 is 0. Point number 5 says the sum of a rational number and its negative is 0. 0 is the only rational number which is its own negative. The difference of two rational numbers is always a rational number. Product of two rational number is always a rational number. The rational number 1 is called the multiplicative identity for rational numbers. 0 has no reciprocal. When a rational number is divided by a non-zero rational number, then the quotient is also a rational number. Now let us try some examples. So in this example, we have let a is equal to 2 by minus 5 and b is equal to 3 by 4. Then we have to verify these two properties. So we will start to see another example. So that means we have to find the another number which would be added to this expression. So the final result will be 3. First of all, we'll write the given part, that is sum of the numbers is equal to 3. One of the numbers is equal to 1 by 2 plus 1 by 3 minus 1 by 5. So we will solve this. We will find the LCM of 2, 3 and 5 which is equal to 30. So the numerator will be 15 plus 10 minus 6 which is equal to 19 by 30. So the other number will be, so now 19 by 30 plus other number is equal to 3. To find the other number, we will subtract 3 and 19 by 30. So the other number will be equal to sum minus one number, that is 3 minus 19 by 30. Now we can write 3 as 3 upon 1. LCM of 1 and 30 is 30. So we will write 30 as common denominator. and this will be equal to 90 minus 19, which is equal to 71. That means that the number is 71 upon 30. Similarly, we have one more example in which we have to simplify this expression. So now here we will solve each of the bracket one by one and then solve the final resultant of each of the brackets. So I hope you can do this example by yourself. We will see our next example now, which says divide the sum of 3 by 5 and 7 by 15 by their difference. So we have to divide the sums by the difference of these two numbers. So first of all, we will find the sum, that is 3 by 5 plus 7 by 15. This will be equal to 9 plus 7 by 15, that is 16 by 15. Then we will find the difference, that is 3 by 5 minus 7 by 15. Again, since denominator is not same, so we will find out the LCM of 5 and 15, which is equal to 15. So this will be 9 minus 7, which is equal to 2. So now we will divide 16 by 15 by 2 by 15. Therefore, the required number will be equal to 16 by 15 divided by 2 by 15. So we will replace the division sign by multiplication sign and write the reciprocal of the second rational number. So this will be equal to 16 by 15 into 15 by 2. Now 15 and 15 both comes in the table of 15, so we will cancel them out. And similarly, 16 and 2 both comes in the table of 2. So 2 ones are 2, 2 8s are 16. So we are left with 8. So that means the required number is 8. Now let us see one more example which says verify the distributivity of multiplication of over addition of rational numbers over their addition. That is x into y plus z is equal to x into y plus y into z. So we have to verify this relation by taking x equal to minus 3 by 5, y equal to 2 by 3 and z equal to minus 2 by 7. So since we have to verify this property, so first of all we will solve the LHS part, that is x into y plus z. So first of all we will put the values of x, y and z in this expression. So this will be equal to minus 3 by 5 into 2 by 3 plus minus 2 by 7. So first of all we will solve the bracket part, that is 2 by 3 plus minus 2 by 7. Since the denominators are different, so we will find the LCM of 3 and 7, which is equal to 21. So this will be equal to 14 minus 6, which is equal to 8. So now we have minus 3 by 5 into 8 by 21. Now 3 and 21 both comes in the table of 3. So we will cancel them out. 3 ones are 3. Since here we have minus 3, so 3 into minus 1 will be equal to minus 3. And 3 sevens are 21. So now we have minus 1 into 8, which is equal to minus 8. And in the denominator we have 5 into 7, which is equal to 35. Now we will solve the RHS part, that is x into y plus x into z. So put the values of x, y and z. And then we will first multiply minus 3 by 5 into 2 by 3. So here minus 3 and 3 can be cancelled out. So we will get minus 2 by 5. Similarly, on solving the other part, we will get 6 by 35. Now we will add both of the rational numbers. So LCM of 5 and 35 is equal to 35. So in the numerator part, we have minus 14 plus 6, that is equal to minus 8. So the final answer is minus 8 by 35. So now as we can see, the LHS and the RHS part are equal. So the above property is proved. I hope the examples up till here. So after practicing all the examples, you have to do all the questions of exercise 1.1 by yourself. Of rational numbers on number line. To represent a rational number p upon q on number line, we have to follow these steps. So step number 1, if p upon q can be expressed as mixed rational number, that is, if we can write p upon q as a plus b upon q, where a is whole number part and b upon q is a proper fraction part with b less than q. So after that, our second step would be if p by q is equal to a plus b by q, then take a on the number line and represent b by q ahead of it. Step number 3 is to represent b by q or p by q. If p by q cannot be expressed as a mixed fraction, divide the unit length on the number line in q parts. Take b parts out of q parts towards the right of a. Better, let us try one example. So in this example, we have to represent the following on the number line. So which we have to find a rational number between two given rational numbers. So suppose we have to find some rational numbers between two given rational numbers, say minus 5 by 9 and 5 by 9. We know that there are 9 integers between minus 5 and 5. That is minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Thus, we can say that the rational numbers minus 4 by 9, minus 3 by 9, minus 2 by 9, minus 1 by 9, up to 4 by 9 lie between minus 5 by 9 and 5 by 9. This is not the limit of finding the rational numbers between minus 5 by 9 and 5 by 9. We can find many more rational numbers between these two rational numbers. Since minus 5 by 9 is equal to minus 5 into 10 upon 9 into 10, that is minus 50 upon 90, and 5 by 9 is equal to 5 into 10 upon 9 into 10, that is 50 by 90. So therefore, minus 49 by 90, minus 48 by 90, minus 47 by 90, up to 49 by 90 are all lie between minus 50 by 90 and 50 by 90. That is, they lie between minus 5 by 9 and 5 by 9. Further, we can write minus 5 by 9 as minus 5 into 100 upon 9 into 100 also. So this will be equal to minus 500 upon 900, and 5 by 9 is equal to 5 into 100 upon 9 into 100, that is 500 upon 900. So there are many other rational numbers like minus 499 upon 900, minus 498 upon 900, so on up to 499 upon 900, which lie between minus 500 upon 900 and 500 upon 900. That is, they lie between minus 5 by 9 and 5 by 9. Thus, we see that there are infinite rational numbers between minus 5 by 9 and 5 by 9. Hence, we can say that the countless rational numbers lie between any two rational numbers. We have one more method also to find the rational numbers between any two given rational numbers. So let us see the other methods to find the rational number between two given rational numbers. Method number 1 have these steps. So let us read them one by one. So step number 1 is express the given rational numbers with the same denominators. Step number 2, find the different values of integers which lie between the numerator part of two rational numbers having same denominator. Found in step number 2 as numerator to express the different rational numbers. So we have one more method. So let us read the steps of method number 2 also. So step number 2 for this method is add the given rational numbers and divide it by 2. Step number 2 says, now we have 3 rational numbers. Again divide the sum of any 2 consecutive rational numbers by 2. We have another 2 new rational numbers. Step number 3, we can repeat the step number 2 as many times as per requirement of finding the rational numbers between any two rational. Let us do one example using both of these methods. So here we have to find the rational numbers between minus 2 by 3 and 1 by 2. First point is a number that can be expressed in the form x upon y, where x and y are integers and y is not equal to 0, is called a rational number. Every natural number is a rational number. Every integer is a rational number. 0 is a rational number. Every fraction is a rational number. Rational numbers are closed under addition, subtraction and multiplication. For rational numbers, the operation of addition and multiplication are commutative and associative. That is, for rational numbers a, b and c, a plus b is equal to b plus a, and a into b is equal to b into a, and a plus b plus c is equal to a plus b plus c. Also, a into b into c is equal to a into b into c. The additive identity for rational numbers is 0. The multiplicative identity for rational number is 1. The additive inverse of a rational number a by b is minus a by b, and vice versa. The multiplicative inverse or reciprocal of a rational number a by b is b by a, where a and b are integers not equal to 0. Rational numbers can be represented on number line. So that is it for today's class. I hope you have understood all the points and all the concepts that we have studied in this chapter. So practice all the questions as much as you can. We will meet in the next class with a new interesting chapter. Till then, take care of yourselves.